Okay, you guys, similarity shortcuts. So much like we figured out, like instead of finding every side and every angle is congruent to prove triangles are congruent, there's shortcuts to show triangles are similar. Okay, big idea is there's three of them: AA, SAS, and SSS. The big difference here, though, is when we say SAS and SSS, what we mean is the sides are proportional. And when you're like, well, what does that mean? I'll talk about it, okay? So sides are proportional, not congruent. Okay, so two big hints here. Find all the angles in triangles. So in this picture, it doesn't look like any angles match of either triangle. But actually, when you split it up, the top triangle is 85, 45, and then you solve and you get the last one is 50 degrees. And the big triangle, oh, look, they both have that 85 on top. They both have a 50, and then you subtract, you get 45. Oh my gosh. They actually all have the same angles. And our first shortcut is, if any two angles match of one triangle to another, then they're similar. So those two triangles are similar. Another one is choose corresponding sides in terms of the SAS and the SSS by the biggest matching, the biggest and the smallest matching the smallest. Don't pick like, I see a 6 and a 6, and those are like matching. So that's how you fall into traps, okay? So example here is when it's saying, are these similar, right? We're going to use side, side, side because we have no angles. So we're going to see if all the sides are proportional. Now what I would do is I would check, okay, so which ones match? So here's the smallest, the medium, and the biggest. Those correspond with smallest, medium, biggest, which correspond with smallest, medium, biggest. So now I know that the three big ones are corresponding to one another, and I'm going to do examples of how to check that these are similar below, but I just wanted, well, why did I circle the smallest on the left triangle with the biggest? So I just wanted to show you that the biggest sides of each of the three triangles, those are the ones that correspond. So those are the ones we're checking if they're proportional. So the way you would check if two sides are proportional is you're seeing if the ratios are equal. So what we're going to say is between these two triangles, and I'm going to color code, do the medium side ratio match the big side ratio, match the small side ratio. So I'm going to do all my ratios in this direction, okay, with this number on top. So what I'm checking is, if I want to check SSS, I'm going to do this below, but why leave a problem unfinished? What I'm checking is the ratio of big on the left to big on the right the same as the ratio of medium on the left to medium on the right? Is that the same as the small on the left to the small on the right? Okay, that's really what I'm asking here is, are these three ratios the same? If they're the same, then that means all three sides are proportional to the three sides of the other triangle. So let's check really quick. This reduces to 4/5. Dividing this by 4, this reduces to 4/5. Or you could just smash it into a calculator and go beep, boop, bop, beep. This one has 0.8. So either reducing, I like fractions, so I reduce. So I would multiply this by 2 on top and bottom. So this one becomes 28 over 35. And then I would divide by 7, and oh golly, I get a 4/5. So all of them did check out. They were all equal to 0.8 or 4/5. So yes, triangles are similar by SSS, triangle similarity, and we're going to do some problems down below this. But yeah, so these two triangles would be similar, and then we would match the order based on the sides. And so I'm going to erase them, or I won't even erase. Okay, so let's do in order from small to medium to large. So that would be triangle C to B to A. That would be from small, medium, large. Okay, CBA would be similar to, and going across small, then medium, then large, that would be LKJ, triangle LKJ, okay? That's how we could prove triangles are similar by SSS, and you would need to show this valid work, okay? Got it. And then we would have to check the other one, and I'm pretty sure actually all three triangles are similar here. All right, so AA similarity, this is our first one, okay? Triangles are similar if and only if two of the angles match two of the angles. The reason 2 is sufficient is actually by the third angle theorem, we know that then the third angle is the same. So really we're saying for two triangles to be similar, all three angles match, but it is sufficient to find two angles, because then just by 180 minus we could get the third, which we already proved was the third angle theorem. So if we ever find two angles matching, then the triangles are similar. So here's some immediate practice with it. Okay, first one, 9. Are these similar? No, we got a right angle and a 42. What was the hint, right? Hint number 1, find all the angles, right? So let's look down here. Okay, I'll find them. In the left triangle, 180 minus, we get 42. Good golly, we've got a right angle and a 42. Then yes, they are congruent. It says determine whether they're similar. If they are, write a similarity statement. So a similarity statement is simply saying triangle, and I can make up any order in the first one. So let's say G, H, F. And then that's similar to, now order matters. So I'm going 48, right angle, 42. 48, right. So that's, this one's the 48 to the right and then to the 42. So it has to be LJK matching. Yes, that's by A, and they're similar by AA. All right, so the next one, 45. We only have one angle. No, just kidding. We have vertical angles. So yes, by AA. Really, it's by vertical angle theorem and then AA. And order is, I'm going to go 45 vertical other. So 45 vertical other. So we get triangle NYM is similar to triangle ZYX. All right, and then the next one, 35. So we have one matching. Do the others match? Well, let's solve. In the first triangle, that's 110, 120, that's 60. Nope, because the other one doesn't have a 60 or an 85. So I know, but let's finish it anyways. Okay, we do 100, we get this is 80. So no, the two triangles have different angles. They are not similar. No. Okay, in the next one, well, we just have 65, but, oh man, we have so much we can use now. Okay, look at this. Boom, parallel, because converse of corresponding angle postulate. So then the other corresponding angles match, and you go, whoa, that's cool. Or we could go, didn't even need that. That was just cool. That was just cool to talk about. I enjoyed that inside my brain, inside my body. It felt good. But look at this. This angle is in both triangles. So we have little triangle with this and 65, and big triangle with that same angle and 65. So by reflexive property, angle C is the same as itself. So already we have yes. We didn't even need that. But then we could also go ka-chow, ka-chow. That means parallel. Ka-chow, ka-chow. So we get yes by AA. And then we have what? Triangle. Let's go ACE. So ACE. So I went 65 this one there. So I'm going to go 65 this one. Okay, so it would be BCD. Similar to triangle BCD. Let's try the next one. Oh, this is the one we did above. So again, it looks like no way, Jose. But then you solve it and you go, wait a second, this is a 50. And in the big triangle, if we subtract from 180, we go, this must be 45. What the hecka? That means in this triangle, I'm going to go 85, 50, other. So that's triangle YZ to X is similar to, so I start with 85, then go 50. So in the outer, it would go 85, 50, other. So it would go YWU. So those are similar. So yes, by AA. And we wrote it there. Okay, I like this like burnt earthy orange color. This is nice. Okay, so we have parallel lines, but we have no angles that are congruent. What the heck? No, just kidding, we do. Both triangles have this angle in them. And parallel lines means corresponding angles are congruent. Oh, and it means these corresponding angles are congruent. So, oh yeah, yes, by A. We have every A in the whole world. And then the triangles, they're in order. So let's just go angle 1, 2, then other. So that's NMP is similar to triangle. And then same order 1 to 2 to other. So NLQ. Cool, so that was using AA. But then we have SSS similarity. So if all three sides of one triangle are proportional to sides of the other, then the triangles are similar. And I broke it down into like symbols, okay? Symbology. So here, two triangles are similar if and only if the ratios of their sides, right? So just literally, AB divided by this, that's one ratio. BC divided by this, that's the other ratio. And then the last one is first and last divided by first and last, right? So if all three of those ratios, right, the ratios of all three corresponding sides are the same, then it's proportional. Because remember, all a proportion is equal ratios. And here we have ratio equal ratio. So that's what it's saying. If they are proportional, because if these aren't equal, it's not a proportion, right? That's just two random ratios that are different. A proportion means two ratios that are equal. So it's saying if all three ratios are the same, then the triangles are similar by SSS. So let's do a problem or two, right? Right here. It's the problem from up above. Let's do it. So is either one of them similar to ABC? So again, we got to match. Here's the biggest with the medium with the small. Here's the biggest with the medium with the small. Here's the biggest with the medium with the small. So we got two different questions to check. We kind of got ABC compared to one and ABC compared to the other. So let's do ABC and LKJ first. All right, so we got the biggest, 20, is to, and so I'm going in this direction for all of them. So these ones are on top, these ones are on bottom in my ratios, okay? So I'm going biggest 20 is to biggest 25. So again, triangle ABC on top, triangle LKJ. Order doesn't matter yet. I don't have a statement. I'm just showing you which triangle. Okay, so biggest is to biggest as medium is to medium. And then as, and then small 14 is to small 17.5. And we already did this problem above. They all simplify to be 4/5, or if you plugged into a calculator, they all simplify to be 0.8. And again, that was because I times by 2 here and here, and I got 28 over 35. And if we're being really correct, these weren't equal. They were question mark equal. Are they equal? And then we go, yes, they are. Woohoo! So yes by SSS, and then we just got to match the order. So I'm going to go with triangle ABC, and then we go similar to triangle. And so what was that? A to B to C was medium small. So if I want to go across medium then small, that's triangle JKL. All right, now total separate question. This is like done. Okay, separate question here. Is ABC similar to the other one? Because it says, is either of these similar to ABC? Okay, well, let's check this out. Again, we go, I'm going to go from ABC to over to here. So the biggest ABC is 20 over the biggest 16 is to medium ABC 16 is to medium on the right, which is 12. And then the biggest or smallest ABC is 14 to the smallest on the right, which is 10.5. And we're just checking, are these three equal? If all three are the same, then they're similar. So let's just check if those three are the same. So this simplifies to be 5/4. The one on the right, we divide by 4, we get, see, we divide this by 4 and we got 5/4. We divide the next one by 4 and we get 4/3. Ouch, we already know the answer is no. And then the right one, I'm going to multiply by 2, we get 28 over 11, or 21. Divide by 7 and we get 4/3. Gosh darn, 2 of them match. These two sides match, but the biggest 20 to the biggest 16 was the wrong ratio, so no. So triangle RST is not similar to triangle ABC. And that's kind of misleading because maybe you could jumble the letters and say that is, but whatever, we'll just leave it like that. Okay, and what about this one? It just tells us random facts. And we go, well, how the heck? Again, if we want to check, we just go, okay, let's go in order from ABC to DEF, and it's saying verify, but we're just going to check, and then it says find the scale factor. So let's find that. Okay, so let's see, that's biggest, medium, small in order. Nice. Big, medium, small in order. Oh, too kind. Thank you, sirs. Okay, so 18 to 12, 15 to 10, 12 to 8. So let's just check. So dividing by 6, we get 3/2. Dividing by 5, we get 3/2. Dividing by 4, we get 3/2. Oh yeah. So again, there really was like question marks here. Are they equal? And yes, they are. So yes, similar by SSS, triangle similarity. Okay, and then we write the ratio. We go, okay, that's triangle ABC is similar to triangle. And now let's check the order. So BC matched EF, so the out of the 3 letters, we know the E and the F go here, okay? And then AB matches with DE, so AB matches with DE. That means it was D, then E, then F. And just to check, AC goes with DF, AC goes with DF. Yes, that's the order. Ooh, that was kind of a fun little puzzle there. Okay, and it says find the scale factor. Well, the scale factor, depending on the order, again, we're going from ABC to DEF because we're going from left to right. That is a ratio of 3 to 2. Again, because I put triangle ABC on top, so the ratio is going from ABC to other, so it's 3 to 2. All right, and then SAS similarity, same thing, but kind of blend of the two. Now we're saying we got 2 sides and the included angle. The 2 sides are proportional. The included angle is congruent, okay? So in this picture, it's easy, right? It just shows you, look, we've got the same angle, and then we've got some scale factor multiple of the original sides, right? So both of them have been multiplied by the same scale factor x. Or another way to say it is, if the 2 sides are proportional and the angle in between them is congruent, then the triangles are similar, okay? I think the picture is so clear. That's a really good picture. Okay, let's try and use it here. Here, okay, we have 1 angle matches. Check, okay? Angle, really clearly it's the included angle. Congruent, check. And now we got to see if the 2 sides sandwiching it are proportional. Again, we match these by biggest and small. So here's the big and the small. Here's the big and the small. So we check, is 15 big, I'll do arrow this way, is 15 to big 10 the same as small 9 on the left to small 6 on the right? Again, this is a question. And so then we check this out and we simplify it. We go 3 over 2 is equal to 3 over 2. Check. And so we go, yes, similar by SAS, triangle similarity. That's just the similarity symbol. Okay, now let's actually figure out the order. So on the left, I'm going to just make up an order. I'm going to say triangle DEF, okay, is similar to, and let's see, so D to E to F, that was right angle across small side, and then hypotenuse. Okay, so right angle, small side, hypotenuse would be WYX. WYX. Groovy. Okay, over here, this is, let's see, oh, we just have the angle in between. Yeah, 112 equals 112 degrees. Check. Now we just need to check, is the biggest with the smallest, going with the biggest and the smallest. Let's check. Okay, let's go this direction. So is 18 to 24, the ratio of the bigs, equal, and go in the same direction as small to small. And so on the left, dividing by 6, we get 3/4. Equals on the right, we get, 4/5. So sad. It was asking a question, and we were denied. Not similar. Okay? Or we could say, not enough information. Maybe there's a circumstance. No. Because there can't be another 112. They're not similar. It's just not similar. Cool questions. Okay, so overall, is every congruent shortcut a similarity shortcut? Well, think about it. SSS, and when we talk about here, we go, this means sides congruent, and this means sides proportional. That's the only difference. But think about it. Look at SSS works on both. So, yup, check. SAS works, yup, check. And all of these other ones have 2 angles in it. So if you have 2 angles, that's enough. Those all fall under AA. So all of the other shortcuts work. Now HL, yes, but we don't use this at all until trig. But you could just use Pythagorean theorem now, right? And I'll actually do a problem like that in just a minute. So if we want to check if 2 HL things are similar, we could just use Pythagorean theorem. So let's actually do that problem. I think it's down, right here. So here's number 6. So are these 2 similar? Well, you go, okay, well, here's an angle and SAS, and here's an angle, and what? Hypotenuse leg, look, this is crazy. We don't have enough. Shoot, dang. But it's a right triangle. So we could just use Pythagorean theorem here. Then we could go, okay, well, this side over here, that's 5 squared plus 10 squared equals c squared. So that's 25 plus 100 equals c squared. So c equals root 125. Or if you simplify that, that's root 25 times root 5. So that's, nope. Yeah. Sorry, I'm doing some, yes. Okay, so c equals 5 root 5. Okay, just to write that out in case that's going to help. And then over here in the other triangle, we go 4 squared plus, I don't know, b squared equals 8 squared. So that's 16 plus b squared equals 64. We subtract the 16, we get b squared is 5448. So b is root 48, which if we simplify, that's b equals root 16 times root 3. So that's b equals 4 root 3. You don't need to do the simplifying the square roots yet. That's actually next chapter. We're getting into that. So now we can check. We go, okay, well, here's an angle. Now let's check the big side. Okay, so is the big side, let's go from this triangle to this triangle. If you don't know which is bigger, 4 is 4. Square root of 3 is bigger than 1, right? Square root of 3 is like 1 point something, 1.7. So that's bigger. So the big on the left is 4 root 3. The big on the right is 10. Is that equal question mark to small on the left 4 to small on the right 5? No, that is not. There's no way to have the square root equal to a perfect 0.8. But you could always like cross multiply and check. So cross multiply, is 20 root 3 equal to 40? Nope. Divide both sides by 20, and is root 3 equal to 2? Nope. Okay, we're sure. Root 3 is 1.7, 2 is 2, so no, not similar. So that was just an example how you can use the Pythagorean theorem to get an answer when otherwise you're like, well, my shortcut doesn't automatically give it to me. So anyways, every congruent shortcut is a similarity shortcut. It's really cool. It's all the exact same, except the ratio isn't 1 to 1. The ratio is any ratio. Oh, wicked cool. All right, let's just do a bunch of homework problems. So is it possible that triangle ABC is not similar to RST and that RST is not similar to EFG, but the ABC is similar to EFG? What the heck? So could triangle ABC be similar to triangle EFG, but triangle ABC is not similar to triangle RST, and that RST is not similar to triangle EFG. At first you're like, whoa, this is complicated. How do I wrap my head around it? This is easy peasy. Okay, let's do a really easy one. Here's ABC. It's an equilateral triangle, 1, 1, 1. Here's triangle EFG. Here's equilateral triangle, 2, 2, 2. Those are similar. All the angles are 60, sides are proportional, whatever. They're similar, okay? And then here's any other triangle, like, I don't know, 2, 3, 4 for, what is it, RST. And so that one is not similar to either of those. So yeah, ABC is not similar to RST, EFG is not similar to RST, but they're similar to each other. So absolutely, yes. All that means is these two are similar and RST is not similar. So yeah, that is totally correct, possible, yeah. All right, down here, Alicia and Jason were writing proportions for the similar triangles shown at the right. Who is correct? So let's see. They're trying to figure out, just maybe solve for a missing side here. So Alicia says R is to K. Okay, so the side not between the 1 and the 2, but outside on the 1. Okay, R to K. That's a good, sure, that works. Those are corresponding. Is the same as S between the 1 and the 2 to M. Yeah, that's totally valid. They cross multiply. RM equals KS. Great. She's got it down. Okay, let's check the other one. Let's delete all that. Okay. R is to K. We could, sure, yeah. We just said that's a good, valid one. And then is the same as M to S. Oh, classic mistake. You can't say ratio this way is ratio this way. That's like saying 2 is to 1 as 1 is to 2. Those are totally different. Double something is very different than half of something. 10 times is very different than 1/10. So flipping the order absolutely mucks up your proportion. So yeah, definitely not true. So this one, they accidentally flipped one of the two sides, and so the arrows were pointing in different directions. No bueno. Okay, let's do another one. So determine which pair of triangles is similar. So for 7, we have no angles. So the only thing we could try is SSS. So let's try it, okay? We got big, medium, small in this triangle. We got big, fractions, medium, small. So let's line them up. I'll do all my fractions in this order. So is 25 big to 8 1/3 the same as medium 21 to medium 7, the same as small 9 to small 3. So we got, these are all questions. Well, that was nice that the last two just simplify right away to be 3 and 3. Well, the first one, let's just figure out. So 8 1/3, that's the same as 24 thirds and 1/3. So that's the same as 25 thirds. And so if we divide here 25 divided by, in parentheses, 25 thirds. Well, let's just do that off to the side. So 25 divided by 25 thirds is the same thing as 25 times 3 25ths. So, and we get 3. So yeah, this is equal to a big fat 3. So check, that is yes by SSS. And we could even write which ones are congruent. So, congruent, similar. So let's do DEF for no apparent reason. And we'll say that's similar to triangle. So I went, DEF is big medium. So big medium would be this way. So that'd be ACB. And that was yes by SSS, triangle similarity. All right, we got one more here. And then we'll just keep doing homework problems because why not, right? So lesson over. Now it's just practice. All right, so this one, we don't have enough information. This is ASS. That's not a shortcut. Get out of here. Just kidding. Calm down. Deep breath. Think about what we got. What kind of triangle is this? Isosceles. You got two things when it's isosceles. One, you want to cut it in half. Everything's symmetrical. Two is base angle theorem. What's up? Well, now we have yes, right? Because these angles are equal. One arc and one arc. And then base angle theorem says both are the same. So yes by AA. And we go triangle. And this is cool. So actually, triangle ABC is both similar to triangle EDF. And separately, triangle ABC is also similar to mirror image EFD because both of them go across from vertex to base base, vertex to base base. So it's actually similar to both. Both of those are correct. Yeah, cool stuff. There's so many ways to look at everything. So just lots of homework problems. So this one, what we gonna do? What we gonna do? Okay, let's do 11 first. Why not? So here we know we have vertical angles. So what we're really checking is, do we have side angle side? Side angle side. So here's big small, big small. So let's see, is big 27. I'm gonna go from this triangle to this triangle. So it's big 27 to 18. Those are big to big. The same as small to small, 21 to 14. Okay, so reducing, let's divide the first one by 9. That's 3 over 2. Divide the next one by 7. That's 3 over 2. Yes by SAS, triangle similarity. Okay, and then let's do the order. So I'm going to do triangle ABC. So that's what? Side nothing and then across small. So across nothing small is DEC. Order has to match, okay? All right, and let's look at the next one here. This one over here, there's a 47. Check. Good. And then big one here and small. And big one here and small. Whoa, that's a S. Okay, and we'll do order this way. So is big 30 to big 50 the same as small 21 is to small 35? Are these the same? And again, on both these questions, this was a question, are they equal? And then we have to go ahead and try and solve. So this is 3/5. That was nice. We divide the one on the right by 7 and we get 3/5. What? Yes. By SAS. Oh, everything's similar to everything. Triangle similarity. And let's write it. So we get triangle. I'm going to make up any letters in the first one. Let's go XZY. XZY is similar to. So I went across big then nothing. So big then nothing would be this way. So that has to be DGJ. Triangle DGJ. J. All right, last one over here on the left. So this one's a little crazy. Like, you're like, what the heck can I do? All right, well, here's the thing, okay? The whole side here is 20. The whole side here is 21, 22. And so what we need to do is compare two separate triangles. One that's a 20, 24, 22 with is it similar to another triangle that's 15, 18, 16.5. And again, where things are rotated, it doesn't matter. What matters is big, small, yada, yada. So let's write it. So here's big, medium, small. Here's big, medium, small. So the question is, and I'm going to do all mine in this order. So is big 24 to big 18 the same ratio as medium 22 to medium 16.5, the same as small 20 to small 15. And again, these are all questions. Are these the same? So let's simplify them. On the left, dividing by 6, I get 4 is 3. In the middle one, I'm going to times by 2. And what that gives me is 44 over 33. Dividing by 11, I get 4 over 3. Hey, looking good. And I divide the last one by 5, and I get 4 is to 3. Again, you could just punch this into your calculator, and you get 1.3 repeating. Punch this into your calculator, 1.3 repeating. Punch this into your calculator, 1.3 repeating. Yes, they are equal. So calculator could do this, but the more you just practice and flex those math muscles, the better for you. So yes by SSS, triangle similarity. And then let's get the order here. So this is going to be triangle, I don't know, let's do small first. So H, J, G. And I'm going to do it here. So I did in this, that was H, J, G. So that was medium big. And so I need to go across medium big. And in the big, and I didn't rotate it. So that's H, K, F. Okay, so H, K, F. Perfect. Now let's just do a bunch more problems. I mean, why not? Okay. Here's another one. Is it possible for these to be similar? Cool. Okay, so we got two triangles. This is JKL and XYZ. So J, K, L, X, Y, Z. All right, so in the first one it says this is 71 and K is 52 and X is 71. And Z is 57. Is it possible? All we got to do is find the missing angle. So on the left one, that's 123. So the last one is 57. And over here on the other, we add them up. That's 128. So the last one is 52. Yes. Whoa. Yes by AA. They have to be. It's not even a maybe. It's not, is it possible? It's definite that yes, they are by AA. Okay, next one. I'm just going to erase the information here. All right, so the next one is we've got a right triangle. Ooh, so we have one of these is a right angle. So all we know is right triangle. We don't know which one's a right angle. Okay. And then it says x plus y is equal to 150. So these two sum to 150. Okay, if those two sum to 150, that means this is a 30-degree angle. All right, so is it possible to have a 30-degree angle in a right triangle? Sure. Let's go right angle, 30, and then what's the other one? 60. And so look at this. Do these sum to 150? Yes. So yeah, yes, possible. And we could even add here, definite. We knew these were, but this one, yes, possible by AA, right? And it's actually a 30, 60, 90 triangle, which we're going to talk about a lot when we get to the section on trig. Okay, so let's get rid of all this. Let's look at the next one. So what if measure J is 87 and measure Y is 94? I mean, what the heck? This is a silly question. Okay, so Y is 94 and J is 87. Let's think about it. If they are the similar, then there has to be a 94 over here. Let's add these two together, and what's that equal to? What? 181 degrees? So this would have to be -1 degrees? That's freaking crazy town. That's not possible. No, not possible. 87 plus 94 is greater than 180 degrees. can't both exist in same triangle, right? And it has to be, all the angles have to match. So if the two triangles are similar, they both have to have an 87 and a 94. So nope, not possible. Ooh, that was a cool one. At first I was like, that's a silly question, but it was deep. It was there. Okay, they're inside our brains. This is good. Measure of j plus k. I'll do it in that burnt orange. Okay, j plus k summed to 85. That means the leftover is what? 100, so 95 over here. Okay, and then the last one is y plus z summed to 80. So that means this is 100. Again, so this is the same question as the last one where it's saying, could we, so we know we have 100 here and we know we have a 95 here. Well, if they're similar, that means there's also 100 over here and a 95 over here, but that can't be, so no. And again, same reason. 195 degrees can't exist in same triangle. Okay, it's like I say they can't exist together. It's like they're fighting. Like, I will win. I will have all the degrees for myself. Okay, let's do this. Okay, so we're going to check just, are they similar? Yes or no? I don't know. Okay, so we got big, medium, small with a big, medium. Nope, this is a big. This is a medium, small. And so we're just checking SSS. That's the only possibility since we have no angles here. I'm late on Zoom. I'll be back. Okay, I'm back. I'm more pumped than ever. Let's do it. Okay, let's see. So let's just set up these ratios and check for SSS. So I'm going to go this direction. So let's say big 15 to big 45. Is that the same as medium 10 to medium 30? I'm like double checking that each thing's medium as I'm talking. That's why I'm saying it so slow. Small 7 to small 21. And then these are all questions. So again, we could smash these into a calculator, or we could elegantly dance with the numbers, and we get 1/3 equals 1/3 equals 1/3. So check yes by SSS triangle similarity, and then we get triangle. I'm going to go small, medium, large. So RQP, small, medium, large, is similar to small, medium, large. That's ONM. ONM. Got it. Next one. Let's see. Ooh, we have an isosceles triangle. Again, we can just use side, side, side. So we got big, big, small, and we got big, big, small. And so is 14. Oh, I was for some reason doing it this way, but that's okay. 14 over 7, the same as 14 over 7, the same as 6 over 3. All of those are questions. And so are those the same? Why, yes. 2 equals 2 equals 2. So same reason, yes by SSS, triangle similarity, and that's, now this is again cool because it's isosceles. We can say RSQ is similar to triangle, and because it's isosceles, you go vertex, base, base. We could either go vertex, base, base, or vertex, base, base, and that's that, like symmetry it has. So it flipped over, it's the same version. So we could either say VTU, or we could say the same triangle similar to VUT. Either one is correct by side, side, side. Okay, let's do more. All right, so here we've got a 75 and 2 sides that aren't sandwiching it. And here we have a 75 and 2 sides that aren't sandwiching it. No, but not no, just not enough info. We just don't know. So if all of a sudden they told us like, oh, this side here was, or this angle was some angle, then ooh, now maybe we know. But right now we just, not enough. So maybe it is, maybe it isn't. We don't know. Next picture. We think no. But curveball, what's waiting in this corner over here? 40 degrees. What? 120 and 40, 120 and 40. Yes. By AA. Okay. And in this triangle, I'm going to go 120, 40. So that's triangle SRT. So 120, 40. Triangle, whoops, similar. Triangle KJL. Yes. Okay. Whoa, look at how many good ones we have. Oh, look at this. This is triangle STU is congruent to triangle STU. So in order, XVW. Or you could say triangle STU is similar to triangle XVW with 1-to-1 ratio. Yeah, it's the same thing. Congruence is just similar with the 1-to-1 ratio. And then over in this next one, it tells us angle's the same. I don't know why they labeled this 48 in one. If we wanted, we could write the 48 in the other one. Cool. But now the question is, does big and small sandwiching it, is that proportional to big and small over here? So let's go in this direction. So is big to big the same as small to small? And yes, it's 1/3 equals 1/3. So we got yes by SAS, triangle similarity. And we have triangle, I'm gonna go ABC. So that's small big. Okay, so ABC goes across small big. So we got across small big is JKL. All right. Okay, 2 more, and then we got a couple different types of problems here. Again, lesson's over. Now I'm just doing cool problems. So parallel lines, so corresponding angles congruent, and both triangles share this angle. So yeah, triangle AC is similar to triangle BDC by AA. That was easy peasy. Okay, next one, we just got to try some decimals. That's it. So what I'm going to do is I'm going to multiply all of these by 10, just so they're easier to deal with. But maybe that's confusing for you. Let's wait and do that, okay? So down here, let's say we got, okay, big, medium, small. Is that big, medium, small? And so over here, now, let's just do it differently. Why not do it differently this time? We've been doing, okay, brute force. Let's just simplify. So let's just delete all those. Let's just try and reduce. So we're going to expand and contract this triangle by the same scale factor and see if we can get this triangle, okay? Well, this triangle over here, we can divide it all by 2. Okay, so this triangle is similar to 21, 15, and 10. Let's see if the other one is. So let's multiply it all by 10 to just get rid of the decimals. So we get 105 and 126 and 60. Then we could divide them all by what? Ooh, that's not good. So this one's a 21 times 5, or 3 times 7 times 5. This one is it has a 5, but this one doesn't have a 5. It has a 3. Does that one? Oh, they're all divisible by 3. So let's divide them all by 3, and we get, this is a 20. And over here, we get, this is a 35. And then over here, if we divide by 3, that's a 42. Okay, we can't, this one's just made of a 2 times 2 times 5, and a 5 doesn't go in here, and a 2 doesn't go in here. So that's as simplified as we can get this one. This is as simplified as we can get that one. They are not the same. They're not similar. So you could set up a proportion, but that was just a different way to look at it. Another way is just, if you want to approach it directly, you just go, okay, well, here's my big, here's my medium, here's my small, here's my big, my medium, and my small, and you can just punch it into a calculator or play with it. So here's 42, I'm going this direction, so 42 to 12.6, is that equal to medium in the right to medium in the left? And then is that the same as small on the right to small on the left? And no, it's not. I could check that right now. I could multiply this by 1.5 or 3/2. If I multiply 1.5, I get, this one is 30 on top, and on bottom I get 9. So right away, these two ratios are not the same. So the answer is no, they are not similar. Okay, so identify the similar triangles and then solve X. Okay, so in this top one, this is a common mistake. We have alternate interior, so they're opposite from one another. So the triangles are flipped in their relation. These two are alternate interiors, they're congruent, and then vertical angles. Okay, so these are similar, so similar by AA, and so what I get is a proportion that's, and I have room to do this below, I'll try and fit it in here at the top. So between the 2 and the 3, if I go from this triangle to this triangle, so x plus 3 relates to, between 2 and 3 in this triangle, that's 2x minus 8. And that's the same as between 1 and 3 to 1 and 3. So that's the same as 5 to 3. So cross multiplying, I get 3 times x plus 3 in parentheses equals 5 times 2x minus 8 in parentheses. So that's 3x plus 9 equals 10x minus 40. That's subtracting 7x. We add the 40, we get 49. So x equals 7. And then we just plug it in. So this was 10 and this over here, plug in 7, we get 14 minus 8 is 6. So if we, right, 14 minus 8, yeah, 6. And so this was like 1 and 2 to 1 and 2, or you can say this was 5/3 of that and 5/3 of that. So yeah, it all double checked. So we got x was 7, we got those lengths. Over here, we get similar by AA because of corresponding angles. And so now here's the common mistake people get into is which triangles are similar. And so the triangles that are similar is this top one with x plus 2 as a side length. And on the right here, we can say, well, if total is 8 and a piece is 5, then the top is 3. So this triangle is similar, and I'm not rotating it. So these are similar lined up correctly. And this is 8. And then on the right, we have to add these together, and we get x plus 8. So the ratio we could set up is x plus 8 is to x plus 2 as 8 is to 3. And then we just cross multiply. So 3 times x plus 8 in parentheses equals 8 times x plus 2 in parentheses, 3x plus 24, 8x plus 16. Subtracting, that's not a 16. Subtracting, we get 5x here, and we get 8 over here, so x equals 5/8. Oh, 8/5 is what I meant to say. And then we just plug it back in, and we could check and get all the lengths they want. Okay, so now let's do these problems. These problems are a little more interesting. So we got, these are similar by AA. It gives us this whole length is x minus 1, and it gives us from C to E is x plus 2, and now it's saying find B, D, and C. Oh, so there's nothing. They just have the triangles overlap for no reason. But here we go. We have these lengths and these lengths. So this is 3 and 8. That's the ratio, right? Those are corresponding sides. Here's an x minus 1. Here's an x plus 2. So these are similar, and we would say, well, from this one to this one, 3 is to 8 as, and then these correspond as x minus 1 is to x plus 2. And then you just solve. But I wanted to show you this triangle over here. Now this one over here, you might say in 21, they're not similar, but here's the thing. In this triangle, you have, I'm just going to flip it over, you have a right angle and this angle A. Okay? And then I'm just going to label the sides. So the height here was 6. Between the right angle and this marked angle is x. Okay, and we don't know the bottom, right? It's some portion, like 12 keeps going, right? Because this this doesn't hit at the vertex, so we don't know the hypotenuse there. All right, but then in the big triangle, we also have that shared angle A and the right angle, and then this is 9. The whole base is 12. We could actually use Pythagorean theorem to solve up here. I know it's a 3, 4, 5 triangle, but if we go 9 squared, plus 12 squared, that's 81, plus 144, that's 225, is c squared. So we end up getting 15 up here. And so that means that 7 plus something equals 15. So actually we know x is equal to 8. We haven't even used any proportions. We just used Pythagorean theorem. And we know these two triangles are similar by AA, right? Because they both share this angle, and they both have a right angle. So by AA, the two triangles are similar. And so now if we wanted, we could set up a proportion to solve missing sides, or we could just use 6 and 8 and Pythagorean theorem get this is 10. Right? Very cool. So I just wanted to show you how in a right triangle we actually have more information. All right, so just determine which of these are similar, and these are going to be our last two problems we do here. All right, so which of these are similar? Oh, these are similar by AA. So, yep. So by AA, we know that, and I'll write the order. Triangle ABC is similar to, and so I want ABC 53 right angle. So 53 right angle would have to be triangle JLK. All right, let's see if there's any other triangle with a right angle and a 53. Well, this one has a 23 if I just 180 minus. If I 180 minus, this one's 63, right? 63. And if I 180 minus, this one's 53. Oh, look at that. And then if I 180 minus over here, this is a 23. So actually, this one is also a 53 right angle. So doing again the 53 right angle, we also have, this is similar to triangle, 53 right angle, IH. G. All right, so all three of those are similar by AA because they all have a 53 degree and a 90 degree. Okay, so then out of the other three that are not similar to those, are they similar to one another? Well, this one's a lone star. There's no other one with a 63 degrees and a 27 degrees. But down here, these bottom two match in orange. These two are similar by AA. And those two, it's because they have a 67 degrees and a 90 degrees. And so the order, I'm going to go 67, 90. So triangle NMO is similar to 6790. That'd be triangle PRS. Perfect. Okay, last problem. Show that the perimeters, so first of all, look at these two triangles. So these two triangles we know are similar by SSS because the ratio of 3A to A is equal to the ratio of 3B to B is the ratio of 3C to C. All of those ratios are 3 to 1, 3 to 1, 3 to 1. Check. So similar by SSS. They told us they were similar in the given, so I erased that part of the problem because I thought that was silly. So SSS triangle similarity because we don't want to mix it up with triangle congruence. They're different things. Okay, so we know which ones correspond with which. Okay, so this angle between A and C, this angle between B and C. Got it. So show that the perimeters have the same ratio. Well, we know the ratio is 3 to 1. Well, let's see. We got A plus B plus C is the small perimeter. The perimeter big is 3A plus 3B plus 3C. So what's the ratio of those? The ratio is 3A plus 3B plus 3C over A plus B plus C. And you're like, well, we can just cancel things. No, 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 no. You can never cancel one thing, right? This bar says everything on top comes in parentheses. But we could actually factor out an entire, watch this, 3 times, and we're just undistributing A plus B plus C over A plus B plus C. Now we have one single term on top, 3 times a parenthesis unit, and on bottom we have one single term, a parenthesis unit. So now the whole A plus B plus C cancels out, and we are left with just 3 over 1. So check. It does have, the whole perimeter has the same ratio. And then that was problem 59. Problem 60 says, if 6 units are added to the lengths of each side, are the triangles still similar? So let's just see. Is the ratio of 3A plus 6 over, so I just literally just plus 6, plus 6, plus 6, and plus 6, because it said to each triangle. So it's saying, is the ratio of 3A plus 6 over A plus 6 the same as 3B plus 6 over B plus 6 equal to 3C plus 6 over C plus 6? So are they still similar? Is that ratio the same? The answer here is no. So this is a common algebraic misconception. Let's just try values here, right? I know algebraically I can't cancel anything out. All I could do on top is factor out a 3 and get A plus 2. But that doesn't help. A plus 2 and A plus 6 are different things, so that doesn't cancel. So instead, let's just try, right? Let's just plug in a number here. If I plug in 1, then on top I get 9, right? 3 plus 6. And on bottom I get 7, so 9 is the 7. If I plug in 2 for B, well then we get that 6 plus 6 is 12 is to 8. But that's a totally different ratio. That reduces to, dividing by 4, that reduces to 3 over 2. If I plug in 3 for C, I get 9 over, I get 9 plus, I get 15, sorry. Over on bottom, plugging in 3, I get 9, and that reduces, dividing by 3, to 5/3. So this one is 1.6, this one is 1.5, and this one over here is, I don't know, let's just say it's 1.4, but it's more like 1.3 something. But no, those are different ratios. So adding 6 actually destroys the similarity. All similarity and proportions are about multiplying by the same number, dividing. It's all multiplication, division to enlarge, zoom, and shrink. If you add, what that does is it takes a rectangle that used to be like 1 by 5, and if you keep adding the same number, like plus 1, plus 1, plus 1, plus 1, plus 1, what you end up getting is something that's like, if I add, say, 100 to both, now I have 101, by 105. It's closer to a square. This was a super long and skinny rectangle. Let's say I added 1,000,000. Well, now I have almost exactly a square. I have 1,000,001 and 1,000,005, right? And now the 5 and the 1 are making a much smaller percent difference. And really, it's just a 1,000,000 by 1,000,000 square with a little margin of error, right? And the more you add the same amount to both, the more it just becomes a square, right? And so, yeah, it totally destroys. None of those are similar to this 1 by 5. So addition breaks that similarity, whereas multiplying by 2 and getting 2 and 10, that keeps the shape similar. Okay, cool problem, you guys. Hope you enjoyed the video.